Understanding scikit-learn's isotonic regression. A detailed explanation. Isotonic regression is a technique used to find a monotonic, either non-decreasing or non-increasing relationship between input features and target values. It's a valuable tool for situations where you suspect or know that the relationship between variables should be monotonic, but the observed data might exhibit noise or deviations. Key concepts. Monotonicity. The core principle of isotonic regression is ensuring that the predicted output values YPRED are monotonically related to the input features X. This means that as the input feature increases, the output value should either never decrease non-decreasing or never increase non-increasing. Regularization. Isotonic regression implicitly applies a form of regularization to the model. It forces the predicted values to be smooth and close to the observed data, while also ensuring monotonicity. Applications. Calibration of probability estimates. Isotonic regression is used to calibrate probability predictions from models like logistic regression to better align with observed outcomes. Smoothing data. It helps remove noise and inconsistencies from data while preserving the overall monotonic trend. Rank aggregation. It can be used to combine rankings from different sources while maintaining a relative ordering of elements. Estimating dose-response curves in biological or medical research. Isotonic regression can be applied to estimate the relationship between drug dosage and response. Scikit-learn's isotonic regression. The isotonic regression class in scikit-learn provides an implementation of this technique. Let's break down the key attributes and methods. 1. Fitx. Y. Purpose. This method trains the isotonic regression model using the provided input features X and target values Y. Inputs. X. A1D array or list of input features. This is the independent variable against which the monotonicity is enforced. Y. A1D array or list of target values. These are the dependent variables that are adjusted to achieve monotonicity. Process. During the fitting process, the algorithm finds the optimal monotonic relationship between X and Y. This involves adjusting the Y values while keeping the order of X intact. 2. Predictix. Purpose. This method uses the trained model to predict target values for new input features. Input. X. A1D array or list of input features for which predictions are to be made. Output returns a 1D array containing the predicted target values. These values are guaranteed to be monotonic with respect to the input features. 3. Fit transform X. Y. Purpose. This method combines the fit and predict operations. It trains the model on the provided data and then applies the model to the same data to obtain predicted target values. Input. X. A1D array or list of input features. Y. A1D array or list of target values. Output returns a 1D array containing the predicted target values. These values are the isotonic transformation of the original Y values. 4. Transform X. Purpose. Applies the learned isotonic transformation to new input features without retraining a model. Input. X. A1D array or list of input features for which transformation is required. Output returns a 1D array containing the transformed target values based on the previously fitted model. 5. Y. Purpose. This attribute stores the adjusted target values after fitting the model that maintain monotonicity with respect to the input features. Type 1D array of floating point numbers. Use this attribute allows you to inspect the adjusted target values and understand the impact of the isotonic regression. 6. X. Purpose. This attribute stores the original input features provided to the model during fitting. Type 1D array or list. Use it provides a reference to the input features used for training. 7. Increasing. Purpose. This Boolean attribute indicates whether the fitted model represents a non-decreasing, increasing true or non-increasing increasing false monotonic relationship. Type Boolean. Use. This attribute informs you about the type of monotonicity enforced by the model. 8. Ties method. Purpose. This attribute defines the method used to handle ties identical input feature values during fitting. Type string. Either average or min. Use. This option controls how the model treats input features with the same value. Average averages the target values corresponding to tied input features. Min uses the minimum target value for tied input features. YAML keys explained. Let's say you are working with a YAML configuration file for your model. Here's an explanation of common keys related to isotonic regression. Isotonic regression. Type. This key usually specifies the class of the model, which would be isotonic regression in this case. Parameters. This section contains the configuration settings for the isotonic regression model. Increasing Boolean. Whether to enforce a non-decreasing true or non-increasing false monotonic relationship. Ties method. String method for handling ties. Either average or min. Min optional. Float. Minimum value allowed for the predicted target values. Max optional. Float. Maximum value allowed for the predicted target values. Example usage. Python. From sklearn. Isotonic import isotonic regression. Import NumPy is NP. Sample data. X NP. Array 1, 2, 3, 4, 5. Y NP. Array 2, 1, 4, 3, 5. Create an isotonic regression model. Model isotonic regression increasing true. Fit the model to the data. Model. Fit X, Y. Predict new target values. New X NP. Array 1.5, 3.5, 5.5. Predictions model. Predict new. Print predicted values. Predictions. This example demonstrates fitting an isotonic regression model to a dataset and then predicting target values for new input features. The increasing true argument ensures that the predicted values are non-decreasing as the input features increase. Conclusion. Isotonic regression is a valuable tool for addressing situations where you need to enforce monotonicity in the relationship between variables. Its simplicity, flexibility, and ease of implementation within scikit-learn make it a powerful technique for various applications, from data smoothing to probability calibration.